Good day everyone. Today we will be presenting on lipids. This presentation will be presented by Muhammad Raziq Irfan, Ahmad Izzat, Muzfirah, Siti Izzati Husna, Auni Waddihah, Nadeeya Zuhayra and Leong Her Jun. Without further ado, let us begin our presentation.
So lipids are fats and fat-like substance. They are classified into three main groups, which are simple, compound and derived lipids. So we go to the first one is simple lipids, which made up of fatty acids and alcohol, usually glycerol. And below simple lipids we have triglycerides, which compose of 1 glycerol and 3 fatty acids. And then we have fatty acid types, which is saturated fatty acids. No double bonds between carbon-carbon chain and it becomes solid at room temperature. And then we have unsaturated fatty acid, meaning that it has the double bonds between carbon-carbon and it become liquid at room temperature. And below that it can be further divided into mono unsaturated fatty acid, meaning it has one double bond only, and poly, it has two or more than two double bonds between carbon-carbon chain. And then we go to the waxes, meaning that it made out of fatty acids and long chain alcohols. And then we go to the second classification of lipids, which is compound lipids, meaning that lipid plus another group, either phosphate or carbohydrates. So first we have phospholipid, so it contains the phosphate group, and then glycolipids, meaning that lipids plus carbohydrate, and below glycolipids we have cerebroside and gangliosides. And then for the last classification is derived lipids. So derived lipids is substance derived from simple ataupun compound lipids, and there are few examples of the derived lipids which is steroids, sterols and carotenoids. So to summarize, lipids are classified into simple lipid, compound lipid and derived lipid.
So lipid consists of four main structure, which is fatty acid, triglyceride, membrane lipid and lipoprotein. Also, yang lastly is eicosanoid. Okay, first is fatty acid. Fatty acid are basic building block for many lipid. They consist of a long hydrocarbon chain, a carboxyl group at one end and methyl group at the other end. So fatty acid can be divided into two types, saturated and unsaturated, which is saturated only have single bond and unsaturated have double bond. The position of this double bond is described using the omega system, which come from the methyl group end. In unsaturated fatty acid, cis configuration mean the chain is bent, while trans configuration mean the chain is straight like mirror image. Okay. Next we have triglyceride. Triglyceride is a storage lipid. They are made by 1 glycerol attached to 3 fatty acid. This structure make triglyceride very high energy and ideal for long-term energy storage in the body. Moving to membrane lipid, also known as glycerol phospholipid. This consists of a glycerol backbone where 2 fatty acids attached to the first 2 carbon and the highly polar phosphate attached to the third carbon. These create the hydrophilic head and the hydrophobic tail, which is essential for forming the cell membrane. We move on to the lipoprotein. Lipoprotein are lipid protein complex that transport lipid in the blood. There are monolayer on the surface, made of phospholipid and free cholesterol, with integral and peripheral lipoprotein on the surface. The core contain triglyceride and cholesterol ester, which are hydrophobic. Finally, we have acecanoid. Acecanoid is a signaling lipid derived from 20 carbon unsaturated fatty acid, mainly arachidonic acid. They are characterized by oxygenated function group and include in prostaglandin leucine, which play a role in inflammation and cell communication.
So next we go to the function of lipid, where lipid can act as the major energy source in human body. Lipid provide approximately 9 kilocalories per gram, which is more than twice what carbohydrate and protein can provide as energy. And they mainly stored in adipose tissue in the form of triglyceride. Next, lipid is part of structural component of cell membrane like phospholipid, glycolipid and cholesterol to form lipid bilayer. Hence, it can create selective mobility to maintain the membrane stability and fluidity to allow proper function of membrane protein. So the third function of lipid is involved in thermal insulation and organ protection, where subcutaneous adipose tissue help in reducing heat loss and maintain the core body temperature. Adipose tissue also can cushion and protect the vital organs such as heart, kidney, and act as shock absorber to reduce the mechanical injury.
I will continue explaining about function of lipid. Lipids, particularly cholesterol, serve as essential precursor for steroid hormone and bile acid. Cholesterol is the parent molecule for all steroid hormone, which include cortisol, aldosterone, which regulate sodium and water balance. Estrogen and progesterone essential for female reproductive function. Testosterone responsible for male reproductive function and secondary sexual characteristic. In addition to hormone, cholesterol is converted in the liver into primary bile acid, namely as cholic acid and chenodeoxycholic acid. These bile acids are crucial for emulsification of dietary fats, enabling function, digestion, and absorption in the intestine. From a clinical perspective, defect in the cholesterol metabolism can result in the reduced steroid hormone synthesis, leading to endocrine disorder. Similarly to cholestasis or impaired bile flow causes the fat malabsorption. Next, dietary lipids are also essential for the absorption of fat-soluble vitamin, especially vitamin A, D, E, and K. Lipid facilitate micelle formation, transport of this vitamin across the intestinal mucosa. When fat absorption is impaired, characteristic vitamin deficiency occur. For example, vitamin A deficiency leads to the night blindness. Vitamin D deficiency causes rickets in the children and osteomalacia in the adults. Vitamin E deficiency may result in the hemolytic anemia and neuropathy. Vitamin K deficiency leads to the bleeding tendency due to the impaired coagulation. Clinically, fat-soluble vitamin deficiency are commonly seen in the conditions such as obstructive jaundice, chronic pancreatitis, and also cystic fibrosis. Finally, lipids play a vital role as cell signaling mediators. A major group of lipid-derived signaling molecules is eicosanoid, synthesis for arachidonic acid. These include prostaglandin, thromboxane, and also leukotrienes. Additionally, phosphatidylinositol derivatives such as IP3 and DAG act as important second messenger in hormone signal transduction. These lipid mediators regulate key physiological processes include inflammation, platelet aggregation, vasodilation, vasoconstriction, and also cellular response to hormone. Clinically, NSAID exerts their effect by inhibiting prostaglandin synthesis, and leukotriene antagonists are widely used in the management of asthma.
Next, we will move to digestion and absorption. I will talk about digestion. So first, dietary lipids are mainly present as triglyceride. In lipid digestion, it begins in the mouth and stomachs with minor contribution from lingual lipase and also gastric lipase. However, the main digestion of lipids occurs in the intestine, specifically duodenum. So the first key step is emulsification, where bile salts from liver break down large fat globules into smaller droplets. This process does not digest the lipids, but it increases the surface area available for enzymatic action, which making the digestion become more efficient. Once emulsified, the pancreatic enzymes will act on the lipid droplets. So the most important enzyme is pancreatic lipase, which will hydrolyze triglycerides into 2 free fatty acids and 2 monoglycerides. Next, we have cholipase, which is another pancreatic secretion which will assist pancreatic lipase by anchoring it to the lipid droplet surface, especially when there is the presence of bile salts. Additionally, we have cholesterol esterase, which will break down cholesterol esters into cholesterol and fatty acids, while phospholipase A2 will hydrolyze phospholipids into lysophospholipids and fatty acids. So the combined action of this enzyme will result in lipid digestion products which are soluble enough to be absorbed. So the products are free fatty acid, monoglycerides, cholesterols, and lysophospholipids.
For the lipid absorption, the lipid digestion product will pack into the micelles. So this micelle will travel through a layer of water to the microvilli on the surface of the intestinal epithelial cells. The other dietary lipids are absorbed in the intestinal epithelial cells, while the bile salts are left behind in the lumen of the gut. For the next slide, the bile salts are extensively reabsorbed when they reach ileum. So 95% of the bile salts are recirculating and traveling through the enterohepatic circulation to the liver. So this bile will secrete as storage in the gallbladder and injection into the intestinal lumen during another digestive cycle. So in the intestinal epithelial cells, fatty acid and also monoacylglycerol are condensed by enzymatic reaction in the smooth endoplasmic reticulum to become triacylglycerol. So intestinal cell will package TG together with protein and other lipid digestion products to become nascent chylomicron. Nascent chylomicron are secreted by the intestinal epithelial cells into the chyle of the lymphatic system and enter the blood through the thoracic duct. So in the blood, the HDL will transfer protein to the nascent chylomicron, particularly ApoE and also ApoC2. So this ApoE will recognized by membrane receptor, and the ApoE bearing lipoprotein will enter hepatocytes by the endocytosis. As for ApoC, it will act as an activator of LPL, which is lipoprotein lipase. So the triacylglycerols of the chylomicron are digested by LPL and release fatty acid. So this fatty acid will bind to the albumin and distributed into other tissue like muscle or adipose tissue and stored there as triacylglycerol stores. And then the glycerol will go back to the liver and will be reused for glycerol synthesis. As for chylomicron, it will bind to the receptor on the hepatocyte and taken up by the process of endocytosis. So the lysosome fused with the endocytic vesicle and the chylomicron are degraded by the lysosomal enzyme.
I'm going to talk about the disease and management related to lipid. And I'll start with the diabetes mellitus type 1, where it's an autoimmune disease where the body immune system destroys the pancreatic beta cells. It will lead to absolute insulin deficiency, meaning the patient cannot produce insulin at all. So insulin therapy will be mandatory for the patient's survival as it will provide the insulin needed by the body. For type 2 diabetes, it's primarily caused by insulin resistance and sometimes combined with the relative insulin deficiency. This means that the body still produces insulin, but the tissue does not respond to it effectively, primarily the GLUT4 transporters. From a lipid perspective, type 2 diabetes often presents with elevated triglycerides and low HDL. The management for type 2 diabetes focuses on glycemic control through medication, lifestyle modification such as weight, exercise, and diet. This approach will help in improving the lipid profiles and also reduce the cardiovascular risk. The last disease I want to talk about is a type 2 hyperlipidemia, also called as the familial hyperbeta-lipoproteinemia. This is a genetic disorder caused by a defect in the LDL receptor, and it will result in LDL clearance from the blood reduced and also elevated LDL cholesterol. High LDL in the blood can penetrate the endothelial layer of the arteries, promoting atherosclerosis and also increases the risk of coronary artery disease. The first-line management will be the statin therapy, where it lowers the cholesterol synthesis in the liver and at the same time increases the LDL receptor expression. This can help in removing LDL from the blood. Lifestyle modifications such as diet and exercise are also recommended to support therapy and reduce cardiovascular risk.